Okay, good afternoon, everyone. This is Steve Smith here in beautiful downtown Silver Spring, Maryland in the VLabForum studios. I'm the host of the VLab and joined here with John Chattel, who is our technical production manager and overall webinar go-to guy. So welcome you all for the October version of the VLab Forum, and just to refresh everyone who has been here before or new listeners, the format of the VLab Forum is we provide like 30 minutes or so of content on a particular research to operations project that is relevant to weather service or NOAA operations, and with the purpose of trying to get an early look in some cases about what's being worked on, or in other cases a glimpse of something that's very mature and it's about to head into operations, in order that we're more prepared for what's coming down the pipe in improvements for weather service and operations. So with that in mind, we would ask that as our speaker goes through, that you hold off your questions until the Q&A period, unless it's something really important like a point of clarification. We do record these sessions, and so immediately after the session's completed, or shortly thereafter, John Chattel will upload the recording of this to the VLabForum website in case you want to refer to it later or share with your colleagues out there. So without further ado, I'd like to introduce our speaker today. It's Dan Halperin of the National Hurricane Center in Miami, Florida. He's going to be talking about probabilistic tropical cyclone genesis forecast guidance tool. And I emphasize the word genesis because that is a particularly tricky but extremely important aspect of the whole tropical cyclone problem. And his colleagues here are Bob Hart, Henry Fjellberg, and Josh Kossuth. Don't know if they're on the line as well, but in any case, I'd like to hand it over to you now, Dan.
Thanks very much for the introduction, and thank you all for the invitation to speak at the Virtual Lab Forum today. One quick point of clarification before we get started. I'm actually not affiliated with the Hurricane Center, but this work is part of a joint hurricane testbed project, so we've been working very closely with folks at the Hurricane Center throughout the development and evaluation of this tool. So we're actually approaching the end of the 2-year project cycle, and so I'm here to report on the status of the project and on the results of the development of the tool. So I'd like to again thank my co-authors Bob Hart, Henry Fjellberg, and Josh Kossuth. So the National Hurricane Center forecasters, as was just mentioned, are interested in tropical cyclone genesis. And specifically, they're interested in guidance products for the Tropical Weather Outlook product, where they issue the categorical and probabilistic genesis forecasts within 2 and 5 days. The global models serve as an important piece of guidance for TC genesis, but sometimes interpreting the raw forecast output can be somewhat subjective. So our goal was to develop an automated and objective TC genesis guidance product that was based on output from 3 global models. So we're aiming to create an objective definition for what constitutes genesis in a model, and then, as I'll show, for each model indicated genesis event, to then provide a bias correction and then provide a probabilistic forecast of genesis. So being that this is something that ideally will be used in operations, there are a couple of things we need to keep in mind. One, the tools need to provide probabilistic forecasts of genesis within 48 and 120 hours to match up with the Tropical Weather Outlook product. We also need to make sure we're covering the entire area of responsibility for the Hurricane Center. So we're issuing forecasts for the North Atlantic and the Eastern North Pacific basins. The products need to be available at least 30 minutes prior to the tropical weather outlook issuance time, so that the forecaster has enough time to consider the guidance tool. And the output products also need to be formatted for quick and easy interpretation to accommodate the forecaster's time constraints. So those were things that we had to keep in mind as we went through development. A general overview for basically what we did for this project: we verified model-indicated Genesis forecasts since 2004 for the 3 global models that are included in the tool, and that is the GFS, the UK Met, and the Canadian global model. And then using that set of historical forecasts, we used logistic regression to calculate objective, bias-corrected Genesis probabilities for the real-time model-indicated Genesis forecasts. And we developed separate regression equations for each global model, each basin, and each forecast window. And in addition to that, developed a consensus-based approach, which includes input from the 3 individual models to develop one consensus probability for each disturbance. So I'll quickly go over some of the methodology, but we want to focus more on the products that are available. But it's important to just show you how we defined Genesis in the forecast fields of the models. We started by looking for a minimum and mean sea level pressure that had at least one closed isobar at a 2 hectopascal interval. Then within 2 degrees of that pressure minimum, and that's indicated by the blue box on the screen, we looked for a relative 850 hectopascal relative vorticity maximum and a thickness maximum at the 250 to 850 hectopascal layer. And then within 5 degrees of the pressure minimum, we recorded the maximum wind speed at 925 hectopascals. The maxima here also had to exceed a threshold value, which was based on each individual model's climatology of what best track tropical depressions looked like in the analysis fields. And all 4 of those criteria had to be satisfied for at least 24 consecutive hours in the forecast cycle before we declared Genesis. So once we have the Genesis forecasts identified, we then verified them according to the following steps. We checked for a time match, so the forecast, we looked for the forecast Genesis time to match with an entry in the best tracks. And if we couldn't find one in the best tracks, we also looked in the ADEX. If there was no time match, we knew immediately that the model Genesis forecast was a false alarm. If there was a time match, we then looked for a position match. So if the forecast Genesis location was within 5 degrees latitude, longitude of that ADEC or BDEC position. If not, again, we have a false alarm. But if so, then we looked at the model initialization time. And keep in mind, we're interested in whether or not Genesis occurs either within 48 or 120 hours. So if the initial time was greater than the 48 or 120 hour period, then we would again have a false alarm. Those would be cases where the model was predicting Genesis too early. If the initial time was within 6 and either the 48 or 120 hour forecast window before the best track Genesis time, then that would be our hit events, our successful Genesis forecasts. And if the initial time was at or after the best track time, we simply discarded the forecast because we didn't want to include Genesis forecasts for disturbances that the Hurricane Center had already begun issuing advisories on.
Hey Dan, this is Steve. So the terminology ADEC, BDEC, what is that?
Sure. So those are the basically large text files that the Hurricane Center has. So the BDECs are the actual best tracks that the Hurricane Center issues, and then the ADECs are also large text files that include operational estimates of position for disturbances. It includes the forecast guidance from a number of the different models, but what we specifically look at when doing the verification is for the forecaster's operational estimate of where a disturbance is located.
Okay, thanks.
Sure. So this is how we identified and verified these historical cases, and then we wanted to run this code now in a real-time setting. So we would identify and track the genesis forecast in the global model fields in a real-time setting according to that same definition of genesis that I showed you. And then we, again, using that historical set of forecasts, created logistic regression equations to give a probabilistic forecast of genesis in real time. So we did it according to the equations here. So the x values would basically be any certain variables that were output by the global models. For example, the surface latent heat flux, the forecast hour of predicted genesis goes in here. So multiplying those output variables by their respective regression coefficients and summing them together will give you this term beta. And then if you plug beta into the equation below, that will give you the probability of genesis within 48 or 120 hours. And so again, we developed a separate equation for each model, each basin, and each forecast window. So the guidance products are available at a website hosted at Florida State University. This is a screenshot of the home page here. So it's not only available to the Hurricane Center forecasters, but also to the general public, although I'm not sure how many people actually know about it. But so this would be your home page. There's an overview graphic here at the top, and then you navigate to the various text and graphical products according to the toolbar here on the left. And you can toggle between the basins here at the top. So I think the easiest way to give you a feel for some of the products that are available is to kind of go through a case study here. So this is the Hurricane Center's tropical weather outlook from 2 a.m. on September 15th of this year. And at the time, there were 3 areas of interest across the North Atlantic Basin with varying probabilities of genesis within 2 days on the left and within 5 days here on the right. So if one was to go to our guidance website at that time, this would be the overview graphic that would be displayed on the home page there. This is the output from the 0Z model guidance on that same day. And what we're showing here is the models that predict genesis, where they're predicting genesis, and then a categorical, the color coding there is the categorical genesis probability within 48 hours. So for the Northwestern Atlantic here, the Canadian and UK Met models were both predicting genesis in this region. The Canadian and UK Met were also predicting a disturbance here over the main development region. And then the GFS and the UK Met predicted yet another disturbance a bit farther east in the main development region. So if we zoom in, or not zoom in, but if we focus in on one of the models in particular, and I'll show the UK Met model guidance because that was the model that actually forecasted genesis for all 3 disturbances. We get a little bit more information now. So the X's are the indicated forecast genesis locations, again color-coded by the categorical probability of genesis. The dots indicate the post-genesis forecast track. The percentages below the X values indicate the regression-based genesis probability. And again, these are the probabilities specifically calibrated for the UK Met model for the North Atlantic at that 48-hour time frame. And so we see a relatively low probability of genesis for the Northwestern Atlantic disturbance, and then mid-range genesis probabilities for the 2 over the main development region. And then below that, we give the forecast hour at which the genesis criteria are met. So the model was forecasting genesis within the 36 to 48-hour time frame here, and then just out over 5 days for the one over the Northwest Atlantic. If we look at the same graphic but now at the 120-hour window, not surprisingly, since we have a larger temporal window now, the probabilities increase a bit, but still fairly low for the disturbance over the Northwest Atlantic, and then getting into the higher categorical probabilities for the disturbances over the main development region. So let's focus on this easternmost disturbance here for a minute, and I'll show you one of the text products that are also available. So this is a system history file, basically, for that easternmost disturbance. So for each initialization time, which is plotted here on the left column, we provide the forecast hour of predicted genesis, the position, and then the 2- and 5-day genesis probability, again, based on the regression equations. So the highlighted entry here is the forecast that corresponds to the graphic on the previous slide, that September 15th at 0Z initialization cycle. And what we can see is that over time, so the older initialization cycles are on the bottom here, with the most recent on the top. And what we can see over time is that the UK Met generally begins to shift westward in its genesis forecast location. So going from around 28 to 30 degrees west to more like 35 to 40 degrees west. So it's shifting westward over time. And you also get a feel for how the probabilities change over time as well. And you generally see a gradual increase in genesis probability leading up to the actual genesis time. So this is nice because it displays trend information for the forecaster. It also provides them with an idea of how consistently a model is predicting genesis. So for this particular disturbance, the UK Met was quite consistent in forecasting genesis for several days prior to the actual genesis time. And it's nice to see that the probabilities are fairly stable in the sense that they're not jumping around. You're not getting 20% for one initialization cycle and then 80% the next. It's a fairly gradual increase, which is certainly helpful. So if we go on to another text part, and don't concern yourself.
Quick question.
Sure.
What was FHR column in that?
That's the forecast hour at which genesis was predicted.
Okay.
Yeah. So the in this particular one, the initialization was on the 18th at 0Z, and the model was meeting the genesis criteria 12 hours later, so 12Z on the 18th.
Okay, so there was an earlier forecast that was supposed to be 18 hours in the future, and that one didn't pan out?
Yeah, so this one here, at this particular cycle, it was forecasting genesis at 18 hours, and then the subsequent cycle decided to delay the onset of genesis. And as it turns out, for this particular disturbance, I believe genesis occurred within 48 hours of this initialization time anyway. So if in the sense of the verification, it would have been considered a hit, because even though the model was forecasting genesis to occur at hour 18, it still occurred within the 48-hour window.
Okay, thank you.
Sure. So, and another text product that we have, I mentioned that the forecasters are sometimes constrained for time, but in the situations where they might have more time to look at some of the details of each forecast disturbance, we issue a more detailed text product here. And don't really concern yourself with the numbers. That's not really important. But the takeaways here are that for each forecast output time, so for each 6-hour output time, which are given by the columns here, we provide a binary yes or no as to whether the genesis criteria are met, the position of the disturbance. The next 3 rows are the values that we use for the genesis definition, so the wind speed max, the vorticity max, and the thickness max. And then below that are the values of the predictors that go into the regression equations. So in this particular example, a low was first detected by our tracking algorithm at forecast hour 42. But you'll notice that the threshold value for the 925 hectopascal wind speed maximum was below the threshold value needed, indicated by the parentheses here. And so our Genesis criteria were not met. And that continued through forecast hour 54, but starting at forecast hour 60, all of the criteria were satisfied, and that continued for at least 24 hours in the forecast cycle. So the algorithm detected a Genesis event at forecast hour 60 here. This product is probably actually most useful for the forecasters when they are looking at the raw model fields and see something that appears like a TC but does not actually show up in our guidance products. And so they can get an idea of perhaps why we were not forecasting Genesis for a particular disturbance. So they can see which threshold values were not met, how close it was to meeting the threshold values, or sometimes the models are only meeting the criteria for maybe 18 hours, not a full 24. They can gain a sense of why Genesis was not being predicted by our guidance tool and just how close it would have been. Okay, moving on to the consensus products now, which I alluded to a bit earlier. We take we conduct a regression also for this consensus product, but instead of using output variables from the single models, we take the Genesis probability from each of the individual models and then do a regression on that to get a consensus-based probability. So if we again consider this easternmost disturbance, the GFS and the UK Met were predicting Genesis for that particular disturbance. There's the G and the U there. The Canadian was not, and so for this beta equation here, we would plug in 0 for the Canadian probability, 0.2 for the GFS probability, and 0.43, which was the UK Met's probability of Genesis within 48 hours. So we plug those numbers in, run the calculation, and it yielded, in this particular case, a 41% chance of Genesis within 48 hours, and a similar Genesis percentage for the other disturbance here over the main development region. In general, we find that if more than one model is forecasting Genesis for the same disturbance, the probability of Genesis notably increases. And that is especially true at the 5-day time frame. So this is the same product except for the 120-hour time frame. And so you'll notice that the consensus probabilities for the eastern two disturbances increases to 90%, even though some of the single model probabilities, so for this eastern disturbance, the single model GFS probability was 51%, and the single model UK Met probability, I believe, was 78%. But when you factor in that both were predicting Genesis for the same disturbance, that consensus-based probability gets nudged up to 90%. And 90% also for the other one over the main development region, but still relatively low probability for the disturbance over the Northwest Atlantic. So finally, this again is a very busy slide, but this is just a text summary product that if the forecaster is kind of in a rush, they can just take a look at the very basic information for each disturbance. So the predicted forecast hour of Genesis, the position of Genesis, and the Genesis probabilities for each of the individual models, and then for the consensus equation as well. So again, this is just something that this is kind of a quick reference sheet they can look at if they're short on time. So if we bring it back now and we compare the tropical weather outlook on the left with the guidance product, the consensus guidance probabilities on the right, we can see that there was good agreement between our product and NHC for this easternmost disturbance, 40% and 41%. Our product was going a little bit lower than NHC for the center disturbance. And then there was some disagreement over the western part of the basin. So NHC had tagged a disturbance here over the Gulf of Mexico, which the models were not predicting genesis for. And conversely, the models were predicting genesis for this disturbance over the Northwest Atlantic that NHC was not including in the outlook. So that's the 48-hour comparison. If we look at the 120-hour comparison, now the guidance products are actually issuing a higher 5-day probability for the disturbances over the main development region compared to the Hurricane Center's tropical weather outlook. And the probabilities are still fairly low for the disturbances over the western part of the basin. And the two over the main development region became Tropical Depression 9 and Tropical Storm Ida, respectively. So overall, this was a case where both the tropical weather outlook and the guidance products did a nice job of differentiating between which disturbances would indeed develop and issue the high probabilities for those, and then which disturbances would not develop. This did not develop, and the one over the Gulf of Mexico did not develop, and only low probabilities were issued there. So that's a general. It's a case illustrating a successful differentiation between the high and the low probability events. So I'd like to now shift gears a little bit and discuss some of the verification statistics of these guidance products during last season, because one case study is nice, but it also we want to see how they performed on a season-wide scale. So to do this, I'll be making use of reliability diagrams, which many of you may be familiar with, but for those who might not be, we're plotting the forecast probability from the regression equations on the x-axis versus the percentage of genesis events that verified as hits on the y-axis. And so ideally, the results will be plotted along this orange diagonal line, which illustrates the so-called perfect reliability. Anything above that indicates the regression equation under-predicting genesis. Anything below that indicates the regression equation over-predicting genesis. So this particular example is the GFS-based regression equation for the North Atlantic at the 48-hour time frame. And we see that overall, the results are, the equation is relatively well calibrated. We're close to that orange diagonal line. Up here where you see just the dots, that indicates probability bins where we had fewer than 5 cases in that bin. So the dots just indicate a small sample size. So I'm going to go ahead and include the rest of the guidance products onto this figure now. And a couple of things to note off the bat. One, this is not a true one-to-one comparison of any of these guidance products. We're including all of the forecasts available for each regression equation. And so there are instances included in this figure here where NHC may have been issuing probabilities for a disturbance that the models were not forecasting, and vice versa. So it's not a direct one-to-one comparison, but it is just a convenient way to show all the guidance products on one graph. So the blue line is the same as the previous figure. It's the GFS-based regression equation. The purple line is the Canadian-based regression equation, and the green line is the UK Met-based regression equation. The black line is the consensus, and the red line is the National Hurricane Center's tropical weather outlook. So some takeaways from this, and again, this is the North Atlantic of 48 hours. Some takeaways are that the Hurricane Center, the GFS, and the Canadian were well calibrated at these lower probability bins, but the Hurricane Center and the Canadian were under predicting at some of the higher probability bins. The consensus and the UK Met were generally over predicting, and you'll notice that we had a relatively small sample size for many of the guidance products out at the higher probability bin. If we look now at the North Atlantic at 120 hours, we see that the Hurricane Center is well calibrated again at the lower probability bins, but begins to under-predict at some of the higher bins. The consensus, the black line, and the Canadian, that purple line, were fairly well calibrated, which was a nice result to see. But the GFS and the UK Met regression equations were over-predicting at most of the probability bins. If we shift over into the Eastern Pacific now, we see that the Hurricane Center and the GFS regression equation were under-predicting at most probability bins. The Canadian was again fairly well calibrated, and the consensus and UK Met regression equations were over-predicting genesis at most bins. And again, we still see that there is a small sample size at some of the higher forecast probability bins. And looking at 120 hours, again, the Hurricane Center and the GFS were under-predicting most of the time. The UK Met and Canadian regression equations were fairly well calibrated, while the consensus was under-predicting at the lower probability bins, but over-predicting at some of the higher probability bins. And so one of the interesting results from this verification is that you'll notice that the Canadian regression equation was very well calibrated for each basin and for each forecast window. And it was interesting because if you do just a historical verification of the genesis events, the Canadian global model tends to have a higher false alarm ratio than some of its counterparts, but it either has maybe more reproducible errors or more consistent biases, such that when you apply a bias correction like logistic regression, you actually get some very well calibrated probabilistic forecast, as we saw here. So that's a comparison of the non-homogeneous set of forecasts, and I'd quickly like to show you a homogeneous comparison now. So here we are comparing the Hurricane Center's tropical weather outlook product in red and the consensus regression equation verification in blue. And these are only cases where the tropical weather outlook and the consensus equation were predicting, were issuing probabilities for the same disturbances at the same time. So this is more of a one-to-one comparison as opposed to the previous graphics. So on the left, we have the North Atlantic at 48 hours. And if you look along the bottom here, this is the number of cases per forecast bin. You can see that we have a very small sample size for most of the forecast probability bins. There's not much we can really take away from this figure. However, if we look toward the 120-hour forecast window, we see that between about 0 and 30% probability, the Hurricane Center is pretty much perfect. I don't think there's any guidance product that is going to beat their reliability in this interval. But we noticed that at the higher forecast probability bins, they had underpredicted genesis a bit last year, which was an area, a probability range where the consensus technique was actually fairly well calibrated. And so this result suggests that one of the primary uses that the Hurricane Center forecasters can probably get from this guidance product is that they can use the consensus probability to potentially alert them as to when it may be appropriate to nudge the genesis probabilities higher at the 5-day forecast window. And if we look at the Eastern Pacific now, again, 48-hour verification is on the left. The tropical weather outlook forecasts were under-predicting a bit, and our consensus forecasts were over-predicting a bit. And at 120 hours, we see somewhat of a similar situation where the consensus product is really probably best calibrated in the 70 to 100% forecast probability range, which is a similar range where the tropical weather outlook forecasts were under-predicting a bit. So again, it implies that this product can be useful in alerting the forecasters as to when they may want to nudge up the 5-day probability. So the current status of the project, these guidance products are being evaluated by the Hurricane Center. We recently had an issue with our data feed getting some of the raw model output to our computing cluster locally, which delayed some of the guidance products, and the forecasters were quick to alert us of the problem. So they've been very helpful in evaluating these products and alerting us as to when something is not quite right. Nearly all components of the products are compatible with the Hurricane Center's IT platform, and there are plans in place to convert the few incompatible scripts to a suitable programming language. And the decision for whether or not this project is implemented operationally is expected early next year. So to summarize, we verified historical model-indicated genesis events since 2004. We then used those historical forecasts to serve as the training set for logistic regression equations that would provide probabilistic genesis forecasts in real time. We have several text and graphical products that currently are available to the Hurricane Specialist Unit. And verification from last season shows that the guidance products are fairly well calibrated and most useful, I think, to the forecasters at the higher forecast probability bins for the 5-day forecast window. So I'd like to acknowledge our joint hurricane testbed points of contact, Eric Blake, Todd Kimberlane, Chris Lancey, Craig Maddox, and Richard Pash, and the joint hurricane testbed itself for providing funding for this research. And with that, I will open it up for questions and discussion. Thank you very much.
And thank you, Dan. Very interesting. So let me turn to John to see if, let me ask people on the line that if you'd like to ask a question, please use the raise your hand feature or provide a chat question in the chat box. If you raise your hand, then we'll unmute the microphone and you can ask the question directly to Dan. Do we have any questions?
I think Joan Bonan may have had a question, although if she says she didn't, I'll understand. She had her hand raised briefly.
Joan, did you want to ask a question?
Yeah, can you hear me?
We sure can.
Okay, great. Yeah, I just wanted to, whose products are these? Are these considered weather service products?
These products are currently, it's part of a joint hurricane testbed project. So the products are currently output at a website hosted by Florida State University. But depending on whether or not the Hurricane Center chooses to implement this product operationally, then if they choose to do so, it would then be transferred over, copied over to their IT platform.
Okay, so if they plan to implement these and make them available to the public, then they will need to go through our 10102 process at the time.
Okay.
If they plan to keep them internal to the Weather Service and only use them as internal guidance, then they're not subject to external comment and review. But if they plan to implement them operationally and make them available to the public on the Hurricane webpage, on Weather Service web pages, then they will need to go through the 10102 process at some point before that happens.
My guess is that it would be just an internal use only product, but I don't know for sure. One of the Hurricane Center points of contact would have to answer that question. But my guess is it would probably be internal only.
Okay, just as long as they're aware that if they do plan to make them available, that they will need to go through the 10102 process prior to doing that.
Thank you.
Thanks.
John, do we have any other
No.
The moment, okay. So Dan, I've got a few questions. One is, so have you looked at this verification in a more like standard kind of CSI construct, since you can you define your event fairly well, and you can verify it fairly well to look at like critical success index, false alarm rate, that kind of thing?
Yes, we have. And so we have a set of statistics, yeah, the ones that you actually just mentioned, the probability detection, false alarm ratio, critical success index. And some of those are available in a paper in Weather and Forecasting, but a more updated version I have that's not currently published. If you like that, I'd be happy to provide those statistics for you.
So do you have off the top of your head kind of ballpark POD, FAR, and CSI for this technique?
The ballpark for the CSI, well, it depends on the model. Generally, the CSIs in general are rarely higher than 0.3 for any given season in any given basin. Recently, some of the models, the false alarm ratio has generally been decreasing over time, which is certainly a positive result. But in terms of, I mean, the only numbers that really stick out are that in general the CSIs are rarely exceed 0.3. Okay.
And when you say basin, I was going to ask for this clarification. I mean, there's only two you're looking at, or are you looking at the Atlantic and the Pacific, or are there other basins?
Right. So this is currently just the North Atlantic and the Eastern Pacific. In theory, this methodology could be applied globally, but given that it's for the Joint Hurricane Testbed, we're primarily focusing on the Hurricane Center's area of responsibility.
Okay. And obviously, genesis can happen in the window from 0 to 48 hours. So how is that handled at the Hurricane Center?
I'm not quite sure I understand the question. How is it handled?
Your product is focused on this 48-hour to 120, that window.
Sorry. So it's the 48-hour products are Genesis at any time between 0 and 48.
Oh, okay.
And the 120 is any time between 0 and 120.
All right. I got it. Okay. So I understand. So in the very short time from the 0 to 48 out 0 to 48 hour period, have you looked at incorporating other types of predictors that are not model-based?
I haven't personally, but there have been other groups that have. For example, Jason Dunyan has led a team with a Genesis index called the Tropical Cyclone Genesis Index, or TCGI, and they include things like the Dvorak T number at the initial time, and I believe they look at some satellite data, if I'm not mistaken. The reason we went with just this pure model only type of product was that it was nice and convenient to only have to have the model fields to work with, but also if we're trying to include some of the observational data, sometimes that requires a disturbance to already exist at the initial time. And the nice thing about just using the models is you can have a 5-day forecast for Genesis and have a probability of Genesis, even if there's no disturbance that is in existence at the initial time.
Okay, yeah, got it. So another question I had was, and you sort of alluded to it on the basically in the way basic requirements you have to get a hit or not is this 24-hour thing. But is, I guess, implicit in this or explicit, is there some sort of the back end, the cessation, when in other words, when a tropical disturbance, if that's the lowest category, would cease being a tropical disturbance, or a tropical cyclone would, basically dissipate? Is the inverse of this process, is that of interest to the Hurricane Center, or interest, just from a science standpoint?
Right. That's an interesting question. So I guess you could say that implicitly, our product, you could say that if it no longer meets the criteria that we have for Genesis, or if it no longer meets the criteria for being a TC, you could kind of implicitly say that it's forecasting dissipation at that point. I would imagine that it is of interest to the Hurricane Center in terms of when dissipation is going to occur. But for some of the cases that might be challenging, especially for like extratropically transitioning cyclones, where they might still have fairly intense wind speeds associated with them, but are just not technically. So there's still a system there, but it might not meet the definition of a purely tropical cyclone. So that's a difficult one to address, but it probably would be of interest, I would think.
Okay. We have any questions from other users? Yeah. Dennis. Let's see. Okay, I'm digging through the slides here again, Dan. So when you're looking on this, when you plotted on the Atlantic Basin, you were plotting you had I'm looking at maybe you can go to the slide that says experimental. It's the Atlantic Basin, and there's these plots for 120 hours UK Met model, and you've got the 3 cyclones with the various positions. Yeah, that one.
Right.
So
yep.
So the one that's off of east of Florida there, the one plus 126 hours. What does that mean compared to the one that's plus 48 plus 36 when this is a 120-hour forecast? I'm a little bit confused about that.
Right. So the 126 is kind of it's an oddity because we're going out to we're issuing a 120-hour forecast, but the 0Z guidance or the 0Z model output is the product that will serve as guidance for the 6Z tropical weather outlook. So because there's that 6-hour offset between the model initial time and the tropical weather outlook time, we actually go 1 6-hour period farther to 126 hours. So that's a little bit confusing, but it's to compensate for the offset between the initial time, the model initialization time, and then when that information will be considered for the next tropical weather outlook.
Okay, thanks. And now getting to this question of the separation between each one of these dots represents a genesis event for the same system, and so when the dots are spread apart, does that indicate that the conditions for genesis were sort of translating from forecast run to forecast run rather rapidly due to the winds or something? Go ahead.
The dots actually, sorry, I don't know if I mentioned this on the actual graphic when I was going through it, but the dots are actually the forecast track after genesis is met in the model. So this is this is where the X is where genesis is forecast to occur, and then the dots are the forecast track out to forecast hour 150 following the time that the genesis criteria are met. So this particular graphic is not giving trend information. It's just showing the forecast track from that cycle.
Okay, so it implies that some of these storms are moving faster than others. Basically, that's all it says.
Correct. Yeah. Each dot is a 6-hour position. Yeah. So it implies speed. Yes.
Okay. So also, just getting back to the operational context of this. So the reason that genesis is so important for tropical systems in the Hurricane Center's operations is that when that occurs, they they change their mode of operations. There's certain things that happen at that point. Is that correct?
I mean, yeah. I mean, that's when the advisories will be initiated. But for a really better explanation of what happens, I would maybe one of the Hurricane Center points of contact are on the line and could better answer that question. But since I'm not actually affiliated with the Hurricane Center, I can't speak to exactly how that changes in their mode of operations. But if somebody's from there is on the line, perhaps they could jump in.
Okay. If not, we'll certainly can contact Chris Lancy and have that discussion offline. I'm sure he's very aware.
Yeah, he is. But the big thing is, when the Genesis is declared, that's when they start issuing the operational advisories on the given system.
Right. Okay. Very good. Well, is there no further questions?
Yeah, I had one I was kind of curious about. I noticed you only use 3 models to come up with the consensus. Do you have any sense of what would happen if you use some of the other models that are available, such as, I guess, the ECMWF and some of the other models you see?
Yes, good question. So we've actually done the historical verification for the ECMWF, and we would include it here, but we don't have access to the real-time forecast fields. If the product is chosen for implementation by the Hurricane Center and they're running the code internally, we can include the ECMWF because they'll have access internally to those forecast fields. So if it does get implemented, we do have plans to add the EC to the suite of models here. The regional models are hard to include on this because in general they're only run once an invest has been declared. And this technique tries to, we don't want to have to rely on an invest existing at the initial time to run the product. But any of the global models in general could be added to this suite.
All right, thank you.
Sure.
All right, Dan, I think we're good from our end here. Again, I want to thank you and your colleagues for taking the time to share this with us, and it's good stuff. I'm glad that folks in academia are working on NOAA's problems, helping us solve them. We certainly can use a helping hand in many of them. So with that, I will remind everyone this session was recorded, and John will let you know when it's up on the webpage to share with others. We have a jam-packed agenda coming up for the fall and winter and early spring here. If you've seen the agenda, if not, I'll just let you know. Next month, November 18th, we've got talk from Bill Lamberson on the Ensemble Situational Awareness Table. Then in December, the Damage Path Toolkit project will be presented by Josh Sheck and Paul Kirkwood. Coming up in January, the the Wharf Hydro Implementation Project will be on the agenda with Brian Cosgrove. Then in February, we're going to hear about the Insight project. Then back in March, we've got more tropical stuff, Tropical Cyclone Wind Tool. We will be presented by Jonathan Blaze. And then all the way out in April, looking way ahead, USWRP project refinement and evaluation of automated high-resolution ensemble-based hazard detection guidance tools for transition to weather operations by Isadora Jankoff from GSD. So that's a mouthful, but that's a really interesting thing. So, mark those things on your calendar if you're interested. And thank everyone, and we will see you back in November. And thanks again, Dan.
Thank you very much for the invitation.